Hello, welcome to this video about heterocyclic chemistry. This is an introduction to heterocycles. Why is there a series of videos about heterocycles? What is it that makes them so important to chemistry and to life and society? Well, first of all, what exactly is a heterocycle? Well, according to UPAC, the International Union of Pure and Applied Chemistry, who is responsible for definitions and nomenclature in chemistry, heterocycles are cyclic compounds having as ring members atoms of at least two different elements. So, cyclic molecules, and in organic chemistry that typically is a carbon backbone with one other atom. So it might be nitrogen, oxygen, sulfur, etc. Now, what's not a heterocycle? Well, cyclic compounds with all the same atoms. So, for example, benzene has got all carbon, or sulfur 8 has got all sulfur. So these are not heterocycles. There must be at least two different elements to make something a heterocycle. But why is it that there is a series of videos about heterocycles? Well, for a start, we can look at chemistry. We can find useful heterocycles across several different areas in chemistry. Heterocycles themselves can be used as nucleophilic catalysts and bases. They can be used as ligands for some of the most important transition metal catalysts. They can be used to mimic nature in organic catalysis, or in general they have useful properties for things like molecular labeling as a dye. Outside of the lab, we can find heterocycles in some of the most important and sophisticated modern polymers. Polybenzimidazoles make up a fire retardant material which is useful for firefighting and in the extreme conditions of space. Xylon is a polybenzimidazole molecule that is the lightest and strongest fibre known to man, and this can be used for things like weather balloons and for the tethers in the wheels of Formula 1 cars. In our homes, heterocycles make up dyes such as indigo, which is the most important dye for denim. We can add them to our foods in things like saccharin, which is an artificial sweetener, and they come out of the gas. They're added to the gas to make it smell, so we can detect it in case there's an emergency. There is a vast array of natural heterocycles, from things like nicotine through caffeine and chocolate, which all contain heterocycles as their most important component, to things black pepper that we add to our food every day. Again, piperine, which is one of the main components of black pepper, contains heterocycles. Some of the most potent natural compounds we know, such as morphine and ergotamine, which is related to LSD, also have heterocycles in as their main components. And in fact, when we look to nature, we can see that nature uses heterocycles in the most important building blocks. So 3 out of the 20 amino acids in man contain heterocycles. Histidine and tryptophan have heterocycles on the ends. Histidine is extremely important in enzyme active sites as a nucleophilic catalyst and to help with hydrogen transfer, as well as being a ligand in some metalloenzymes. Tryptophan is related to things like morphine and LSD, so it's a key precursor to neurochemicals, and also to vitamin B3. Proline, the only secondary amino acid, is cyclic, and that's really important because it can both bring stability to proteins as well as disrupting stability where appropriate. Within DNA, there are 2 types of heterocycles. The backbone is made up of a ribose, whereas the key binding between the double helix, the base pairs, are made up by hydrogen bonding within heterocyclic motifs. It's the same for RNA with only slight adjustments. So given the importance of heterocycles, and especially in natural settings, it is no surprise that drug molecules often contain heterocycles. If we look at the 200 top-selling drugs of 2019, and you can look at this yourself if you follow the link to the poster, what we'll find is of those 200 drug molecules, there is only very few that contain no heterocycles. Here, they're labelled in red. The ones in green all explicitly contain a heterocycle, whereas the ones in white are biological molecules, things like proteins, and we've seen already that amino acids contain heterocycles. If we look at FDA-approved drug molecules, we can see that nitrogen-containing heterocycles are particularly important, with 11% of drug molecules containing piperidine, 10% of pyridine, 9% of piperazine, 6% this beta-lactam, which is common in antibiotics, and 6% of polydine. Now, if you think about the wide range of different drug molecules, this is a remarkable percentage. So overall, we've seen that heterocycles are cyclic compounds having atoms from two different elements in their ring. And we've seen how heterocycles are super important in everything from materials to everyday items, our own natural building blocks, and the drug molecules that fight diseases. Thank you for watching. I'll see you next time.